Okay, so today we're moving on to slope and similar triangles. So we'll have some triangles, usually on a coordinate plane, and we're going to talk about slope. So in order to do that, what first we're going to do is kind of a refresher. This one says, use the coordinate plane on the back of your whiteboard to graph the following points. Use the scale factor provided and find the slope of the dilation. So I'm going to graph A and B in green. So I've got A is at 1, 4, B is at 2, 6, B is at 2, 5, 6, and it says 2, we're going to find the slope there, and then we've got A prime and B prime, oh, and the scale factor is 2. So, if we make this twice as big, we're going to do that on our paper, twice as big, we'd go to 2, 8, 2 times 2 is 4, and 6 times 2 is 12. So A prime is at 2, 8, 6, 7, 8, and B prime is at 4, 12. 3, 4, 10, 11, 12. So it should look about twice the length. Now it says find the slope of the dilation. So remember when we were doing slope, we counted rise over run. So this rises 2 and runs 1. This one rises 4 and runs 2. So this slope is 2 over 1, or 2. This slope, rise or run, is 4 over 2, or 2. So even when we dilated it by a factor of 2, the slope stayed the same. So I'm going to write 2 over 1, which equals 2, 4 over 2, which equals 2. Now we would do this one as again in class, but for the video's sake, I'm not going to do that. You would just find that the slope also stays the same even when you make it a fourth of the size. Could we have done the same thing without graphing? So could we have not used a coordinate plane to find the slope? And the answer is yes. We could have done y2 minus y1 over x2 minus x1. And this one would have been 6 minus 4 over 12 minus 8, which in this case, if we're talking, A prime should have gone first. Oh, and I did these backwards. Oh, okay, so 12 minus 8 over 4 minus 2. This is for the A prime, which is 4 over 2, and we got a slope of 2. If we did the same thing here, it would have been 6 minus 4 over 2 minus 1, 2 over 1, which equals 2. So since these are the same, we would have found that the slope between those 2 points is the same. So we would do that in class with that one as well. But we're just going to move on for video's sake. Similar triangles in the coordinate plane. In the figure, triangle ABC, and BDE are slope triangles. So they have the same hypotenuse, basically, is what that's saying. These two, ABC and BDE, they share the same hypotenuse, and since they share the same hypotenuse, they're automatically going to be similar. Which they would check those here. This is a different problem. Finding the slope. The ratio of the rise to the run, which is the slope, rise over run, of two slope triangles formed is a line equal to the slope of the line. So we're going to practice just finding the slope between those. So if we go down to slide 3, they ask us to write a proportion comparing the rise to the run for each of the similar slope triangles shown above, which is actually right here. Then find the numeric value. So what that means is if we're going to find the proportion, all I'm asking you to do is write down what sides you're putting over what. So for triangle ABC, that would be that the rise is the side AC over the side BC. For triangle BDE, that would be side BE over side DE. Now we're going to plug the numbers in. So AC is 1, 2, 3, 4, 5 over 1, 2, 3. BE is 1, 2, 3 over 2. I might have counted this wrong. I did. 1, 2, 3, 4, 5, 6. Redrawing it, cut it off, and we get 2. And BE is 1, 2, 3 boxes over 1. Oh, I drew this completely wrong. This is 1, 2, 3, 4, all the way down over 2. Criminy. Maybe I should stop coloring them. And we get the ratio and the numeric value is 2. So this is all of what I'm asking you to do on your homework. And that the 2's are equal, so therefore they are similar. Because slope triangles are similar. Because triangles are the same slope. So it's asking us to graph triangle M and O with vertices 3, 1. So 3, 1, that's M. N is 1, 0. And O is 3, 0. And PQR with 5, 2. So 1, 2, 3, 4, 5, 1, 2. That's P. Q is -1, -1. Q. And R is 5, -1. So we're going to see here that the lines, the hypotenuse of both are repeats, so that they are slope triangles, and that they're going to be similar. Then write a proportion comparing the rise to run for each of the similar slope triangles. Okay, so for triangle MNO, that's going to be the ratio of MO over NO, which is 1 over 2. For triangle P, I went M and O, so PQR, that's going to be PR over QR, trying to make sure I get my notation here, and that's 1, 2, 3 over 1, 2, 3, 4, 5, 6, which simplifies to a half. So there's our proof that the slope is the same, so they are similar. Here's some just different types of pictures. The plans for a teeter-totter are shown at the right using the points G and L. Let's see if my highlighter fails me again. G and L. Find the slope of the teeter-totter. Then verify that the slope is the same at a different location by choosing a different set of points. So for the next one, let's use G and H. So between G and L, that's going to be the rise, so let's count it. The rise is 2, and the run is 1, 2, 3, 4, 5, 6, which is 1/3. So now let's check between G and H, and that's a rise of 1 and a run of 3. So therefore, they are similar. The plans for a set of stairs are shown below using the points X and Z. Find the slope of the line, then verify that with the same one. So maybe we use X and W. So X and Z, oh, jeepers, X and Z. So between X, Z, we see the rise over the run is 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, which simplifies to 2/3. And then if I did the same thing between X and W, we'd rise 2 and run 3. So they're similar because the slopes are the same. Now shifting your mind to a totally different gear, because slope triangles is just finding the slope. We've got a little review here. So how would we solve these? A map has a scale of 3 centimeters and is in real life 18 kilometers. If Riverside and Smithville are 54 kilometers apart, then they are how far apart on the map? So a couple of ways to solve these. One would be to find the scale factor, and the other would be to set up a proportion. I'm going to set up a proportion. 3 is to 18 as matching my units. X is to 54. So I'm going to cross multiply and get 18x equals times 54, 103 times 54, 162. Divide both sides by 18. We get 9. So this would be 9 centimeters. Another way to do that is to recognize that from 3 to 18 is times 6. So we would have to go back, divide 6, and 54 divided by 6 is 9. So just another way to recognize numbers. So here's another one. You're going to have some of these on your homework. We've got x is going to relate to 7. These figures are similar. We've got 10 to 90, 4 to 36. These two, you might be able to see something, 4 to 36. These numbers are a little harder, but I can see that this one is 9 times bigger than this one. 10 to 90 is times 9. So if I need to go backwards, oh, sorry, no, I'm going back to from 7 to what? So I can just take 7 times 9 and get 63, no label. Those are, that's a scale factor, that this is 9 times bigger, or that this is 1/9 the size. Another way to have done that would be to 10 over 90 equals 7 over x. We could multiply and get 10x equals 630. Divide both sides by 10 and end up with x equals 63 again. So it kind of depends on your number sense and what you can see. I've missed more than 9,000 shots in my career. I've lost almost 300 games. 26 times I've been trusted to take the game-winning shot and missed. I failed over and over and over again in my life, and that is why I succeed. Have a great day.